So we were talking about pure aloha. So let's see how it works from beginning. So a station has got a frame, wants to start sending that frame. So I set the counter to 0 at the beginning. Now send the frame. And then you need to wait for 2 times 2p. TP is the maximum propagation time. Why? Because if a collision happens, then you need to wait. If the frame is delivered, you have to wait for the acknowledgement to arrive. So the two furthest apart stations, the time from this station to this is TP, propagation time, and you get to get to the other point, you need TP. For the acknowledgement to arrive, you need another TP, so you need to wait 2 times 2p. So if acknowledgement is delivered, then that means the receiver received the packet without any problem, but you may get the acknowledgement may not be delivered. In this case, you increment k, you say k equals k plus 1, and now check if you tried too many times. If you tried, for example, 15 times, which is in this case we said that 15 is the maximum number of attempts. So if you try 15 times or more, then stop the attempts. You may try sometime later because you think that the channel is busy or there is something wrong, then you will try later. But if you are it was your first attempt, then just increment k. It was 0, now it will be 1. So you increment k and try again. Okay, now I made k1. K is less than 15, so I will not immediately send the packet. Okay, I'll choose a random number between 0 and 2k minus 1. So in this case, k is 1. Okay, 2 to power 1 minus 1, which is 1. So a random number between 0 and 1. It's a random number, so it can be 0 or 1. You choose it and then multiply that R by TP or multiply it by TFR. So you wait for this amount of time, okay, wait TB, which equals this R generated here times TP or times TFR, and then try again, send the frame again, see if it is delivered or not. If it's not delivered, now K is, it was 1, it will be 2. Now you generate a random number between 2 is less than 15, so you can continue. 2 to 2 minus 1, which is 4 minus 1, which is 3. So you generate a random number between 0 to 3. So it can be either 0, 1, 2, 3. One of them times, this is R now, 1 times 2 TP times TP. Wait this amount of time. So wait 1 time TP or 2 times, it's randomly, you choose a random number between 0 and 3. Okay, so why you will discuss later why we choose a random number, not constant, and so on. So you continue until the frame either is delivered, you attempted 15 times, and in one of these attempts it was delivered, or you attempted 15 times and the next time You attempted and then it was not delivered, then you abort now and try later. This is the pure Aloha protocol. There is a term called vulnerable time. Vulnerable time is the length of time in which there is a possibility of collision. Okay, so what we mean by vulnerable time is the time when you send a frame and that there is a possibility of collision to happen. In pure Aloha, the vulnerable time is 2 times TFR. TFR is a frame time. TFR, for example, you have a frame, you need a time to send this frame. So this is TFR, the time to send this frame, because the frame is data, so depending on data rate, TFR will change. Now let's see how this is calculated or measured. So if station B, this station B started its transmission, it has got a frame to send. Station B started at t equals, okay, so station B started to send its frame at t at time equal t, okay, and this is its frame. Look here, it's not only one station accessing the channel, so there are many other stations like A, C, and so on. So if A started before B, any time after this time, T minus TFR, which means after this, because we are assuming that TFR is same for all of them. So this is TFR, this is TFR, they are same. So if that transmission of A started after this, they will collide, of course. There will be some time then when they overlap or collide. Okay, so this is where collision, there is a possibility of collision if A started its transmission after T minus TFR. But if it started here, it will end before B starts, so there will be no collision. If it started anywhere before this time, but if it started after this time, it will always be colliding with this frame. So even if one single bit from this frame collides a single bit with these, will be damaged. Okay, so you have to start, A should start before, or at least here at T minus 1 TFR. If it started to send after this, then the collision will happen. But station C, for example, if station C started its transmission while station B is still transmitting, okay, so there is also possibility of collision. So if C started at T plus TFR any time before this time, it will collide. But if it started any time after this time, there will be no collision. Any time before this time, there will always be collision. Okay, so the time where collision happens is this time now, is this time, which is, this is 1 TP, and this is TFR, and this is another TFR. So it's 2 times TFR. So the vulnerable time for pure Aloha is 2 times TFR. The vulnerable time is long, so the possibility of collision can happen any time in this collision can happen anytime in this time window. Slotted Aloha was invented to improve the efficiency of pure Aloha. Okay, so to make the collisions less, time is divided in slotted Aloha from name into time slots. See, it's slotted. So this time slot 1, time slot 2, time slot 3, and so on. So we have time slots now. Slots of TFR. So this slot 1, it will be equal to TFR, or the average TFR, sorry, average frame time. Time is divided into TF slots, and the station is forced to send only at the beginning of the time slot. So you cannot send a frame here, go into 2 slots. You should start only at the beginning of a slot, only at the beginning, okay? There is still the possibility of collision. How? If 2 stations send their frames at the beginning of a slot. So in this case, no one sent at the beginning of this slot, only station 1, no other station, so there is no collision. Here, station 2 and 3 sent their frames, so there is collision, of course, both will damage. Here, 2 stations sent at the beginning and they are damaged. Here, only station 2 sent, so there is no collision, and so on. Slotted Aloha vulnerable time is very clear here. The vulnerable time is only TFR, because you see it's only during this slot that collisions can happen. So the vulnerable time is only TFR, which is better than pure Aloha, which was. So we want to minimize the vulnerable time, or reduce the possibility of collisions. We have the carrier sense multiple access protocol, which is devised to reduce the possibility of collision. Carrier sense multiple access works by sensing the channel or medium. So chances of collision can be reduced if a station senses the medium before trying to send. Okay, so here, for example, 2 stations access the channel at the same time. So in this case, in slotted Aloha, we don't sense the channel, we just send. Okay, you don't care if it's free or busy. But in carrier sense multiple access, we sense the channel to check if it's free or busy. But still we cannot eliminate the collisions. Why? Because when you send a frame, for example here, B sends the frame over the channel. This frame will not go instantly to D. Why? Because it travels a maximum speed of light. So it cannot travel instantly to, so D will not know instantly that B is sending. It needs some time. So in this case, for example, C is sending. Until D knows that C is sending, it needs this. Until D knows that B is sending, look, it needs this time period. So you cannot tell instantly if the channel is busy or free. So in this case, for example, B started to send its data, because it sensed and there was nothing. It sensed there was nothing on the channel. Channel was idle. But at this point, look, C also sensed the channel. This is not yet arrived here. This beginning of this frame is still not arrived here. So C sensed the channel. It saw the channel free. Therefore, it also sent its data. So it's the beginning of, this is the beginning of frame C's frame. So when it's sent, because there is still data coming in this direction, they will collide at this point. So collision will happen, and the data, B's data and C's data will both be damaged. Okay, so they both need to resend their data. You see this beginning of the B's frame. This is the end of B's frame. This is the beginning of A's frame. And this is the end of A's frame. So in this area, gray area, both frames exist. C, and which means there is collision. So when D will sense collision, you see here the collision happened. So this collision, of course, needs time to propagate also. So it needs to, so here D will sense the collision, and here A will sense the collision, and here B also will sense the collision. Okay, when it senses the collision, look here, the collision happened. B doesn't know that, still doesn't know that a collision happened. It will still continue its transmission until here. At this time, the collision signal arrived here. B will notice there is a collision, it will stop. And same for D, same for other. So when there is a collision detected, they will stop and then call the backup algorithm. The vulnerable time for current sense multiple access is a propagation time. We'll see here. So if the first bit of the frame reaches the end of the medium, every station already have heard a bit and will refrain from sending. So A is sending a frame, okay, and D is the furthest station. So from here to here, you have the propagation time, or TP, because as I said, TP is the time to go from the first station to the furthest station, or to the go between two furthest stations. So A and D are the furthest station in this case. So time from here to here is the TP. This is TP. So you see, T1 is sending, okay. A is sending at T1. B here doesn't know that T is sending. A is sending. So if it starts sending at T1, collision will happen, because at some point this data will arrive here and collision will happen. Okay, so there is possibility of collision if B starts sending at this time, until this time. Okay, now C, if C sends data, if it starts here, it can't send, because it will sense the channel. The channel is empty because this data is not arrived yet. It needs time. So at this time, it arrived. So if C sends data at any of these intervals, collision will happen. And now again for D. So D would know that A is sending data after this time, because it needs to propagate. So if it sends data in this time period interval, collision will happen. Therefore, that Vulnerable time is TP. So none of these stations should send data in this time period so that collision does not happen. Station A sends a frame at T1, as we said, which reaches station D at time equal T1 plus TP. This is TP. So this is T1 plus TP. We have different persistence methods. Persistence method is what should a station do if the channel is busy, and what should the should a station do if the channel is idle. So you have two cases: either the channel is busy or the channel is idle. We have three methods that have been devised to answer these questions. We have the one persistent method, non-persistent method, and p-persistent methods. So in what persistent method, okay, you after a station finds the line idle, it sends its frame immediately with probability of 1, of course. So you just continuously sense the channel, okay? You continuously sense the medium. Is it busy or idle? If it's busy, sense until you find the channel idle. So in this case, time period is idle, just transmit your data. Don't wait, don't do anything. This method has the highest chance of collision. Why? Because two or more, maybe another station is also doing the same. Is sensing and check the medium at this point, and it idle, and it's also started sending its frame. Therefore, there is a high possibility of collision with this one persistent method. Ethernet actually uses this method. We study Ethernet protocols later in another chapter. So it is used in Ethernet. It's simple. You continuously sense the channel. If it's busy, just continue to sense. If you find it idle, don't do anything. Just send. Don't wait. Don't do anything. But it's, as we said, there's a high possibility of collision in this persistent method. Another persistence method is non-persistent. In this case, a station that has a frame to send senses the line. If the line is idle, it sends immediately. Okay, so you sense. Here you sensed, okay, the line was here. You sensed the line was idle, no transmission going on, so transmit. But if the line is busy, so here you sensed the line was busy, there is another station sending. It waits, look, the difference here, if the line is busy, wait a random amount of time. Okay, so this wait is random. You see, here's a wait, here's another wait, but their times are different. This wait is longer than, so it's a random wait. Okay, what's the advantage of this method over the other one? You see here there is continuous sense. So two channels, two stations may the same time see the medium idle and send the data, but in this method, because there is random wait, so the possibility of collision would be less. because another channel, another station may be sensing, and it sensed here, for example, okay, and it saw the channel busy. It called a wait, random wait, but it's this wait and this wait were different. Therefore, they will not send at the same time. Okay, so this now, since the channel, it called a wait again, random wait, but this one, you see, will start sending here. So when it sends another time, when this random wait expires, the timer, it will sense now there is another station sending. So the possibility of collision will be less. So it reduces collisions, because it's unlikely that two or more stations have to wait the same amount of time. Okay, because this wait is random, it's not constant. But it reduces the efficiency of the network, because the medium remains idle when there may be stations with frames to send. So it reduces collisions, but it also reduces the efficiency, because you see, maybe another one is calling wait. Because of these random waits, the channel is idle, no one is using it, but two or more stations are calling their random wait timers at this point. There is a more sophisticated method, which is called p-persistent method. P-persistent method is used if the channel has time slots, okay, so like slotted aloha, with a slot duration equal to or greater than maximum propagation time. The p-persistent approach combines the advantage of the other two strategies, which means non-persistent and one-persistent. It reduces chances of collision and improves efficiency. So we have both advantages. In this method, after a station finds the line idle, it follows these steps. With probability of p, the station sends its frame. Okay, so continuously sends. Send if r less than p. So there is a random number generated. Check that random. You have if it's less than p, wait for another slot. If it's okay, if it's less than p, wait. With probability q equals 1 minus p, the station waits for the beginning of the next time slot, checks the line again. Okay, so if probability q, which equals 1 minus p, the station waits for the beginning of the next time slot. So you see, it's slots. Okay, if the line is idle, it goes to step 1. We see the flow chart. If the line is busy, it acts as though a collision has occurred and uses a backup procedure. We see the backup procedures later. So these are the three persistent methods. The one persistent, okay, the you see here, channel busy, sense. If it's not busy, false, it's not busy, then you can't transmit. In non-persistent, you check the channel is busy. If it's busy, you see, if it's busy, wait random amount. Here you don't wait, just continue sensing. If it's not busy, you can't transmit. In the P persistent, it's like, you see here, it's like this one. So one persistent here. So check continuously. If the channel is busy, check continuously. If it's not busy, then generate a random number r equal between 0 to 1. Okay, depending on the number generated, okay, compare r is, you set this for example to some number, is less or equal to p. If true, then you can send, but if r, the generated number, is not less or equal to p, then wait a slot. Okay, because they said this is used in slotted protocols, not in any protocol, so you have to wait to the next slot. Okay, now check again, the channel is busy. If it's busy, call the back off. If it's not busy, go to this step and repeat again. Okay, so these are the three persistent methods.